OCR-A is a font that arose in the early days of computer optical character recognition when there was a need for a font that could be recognized not only by the computers of that day, but also by humans. OCR-A uses simple, thick strokes to form recognizable characters. The font is monospaced, with the printer required to place glyphs 699925400000000 unregistered trademark 0.254 cm apart, and the reader required to accept any spacing between 699922860000000 unregistered trademark 0.2286 cm and 699945720000000A. Unregistered trademark 0.4572 cm. Standardization. The OCR-A font was standardized by the American National Standards Institute as ANSI X3.17-1981. X3.4 has since become the INSITS and the OCR-A standard is now called ISO 1073-1 1976. There is also a German standard for OCR-A called DIN 66008. Implementations. In 1968, American type founders produced OCR-A, one of the first optical character recognition typefaces to meet the criteria set by the U.S. Bureau of Standards. The design is simple so that it can be easily read by a machine, but it is more difficult for the human eye to read. As metal type gave way to computer-based typesetting, Tor Lindqvist used meter font to describe the OCR-A font. That definition was subsequently improved by Richard B. Wales. Their work is available from CTAN. To make the free version of the font more accessible to users of Microsoft Windows, John Soter converted the meter font definitions to TrueType using Portrace and FontForge in 2004. In 2007, GAR 1/4 aka Nsengel 1/4 N created a Debian package from this implementation. In 2008, Luc Devroy corrected the vertical positioning in John Soter's implementation, and fixed the name of lowercase z. Independently, Matthew Scala used Portrace to convert the metafont definitions to TrueType format in 2006. In 2011 he released a new version created by rewriting the metafont definitions to work with METATYPE1, generating outlines directly without an intermediate tracing step. On September 27, 2012, he updated his implementation to version 0.2. In addition to these free implementations of OCR-A, there are also implementations sold by several vendors. Use. Although optical character recognition technology has advanced to the point where such simple fonts are no longer necessary, the OCR-A font has remained in use. Its usage remains widespread in the encoding of checks around the world. Some lockbox companies still insist that the account number and amount owed on a bill return form be printed in OCR-A. Also, because of its unusual look, it is sometimes used in advertising and display graphics. Code points. A font is a set of character shapes, or glyphs. For a computer to use a font, each glyph must be assigned a code point in a character set. When OCR-A was being standardized, the usual character coding was the American Standard Code for Information Interchange or ASCII. Not all of the glyphs of OCR-A fit into ASCII, and for 5 of the characters there were alternate glyphs, which might have suggested the need for a second font. However, for convenience and efficiency, all of the glyphs were expected to be accessible in a single font using ASCII coding, with the additional characters placed at coding points that would otherwise have been unused. The modern descendant of ASCII is Unicode, also known as ISO 10646. Unicode contains ASCII and has special provisions for OCR characters, so some implementations of OCR-A have looked to Unicode for guidance on character code assignments. Space, digits, and unaccented letters equals. All implementations of OCR-A use U+0020 for space, U+0030 U+0039 for the decimal digits, U+0041 through U+0058 for the unaccented uppercase letters, and U+0061 through U+007A for the unaccented lowercase letters. Regular characters equals. In addition to the digits and unaccented letters, many of the characters of OCR-A have obvious code points in ASCII. Of those that do not, Most, including all of OCR-A's accented letters, have obvious code points in Unicode. Equals remaining characters equals, Linotype coded the remaining characters of OCR-A as follows. Equals additional characters equals, the fonts that descend from the work of Tor Lindqvist and Richard B. Wales define 4 characters not in OCR-A to fill out the ASCII character set. These shapes use the same style as the OCR-A character shapes. They are, Linotype also defines additional characters. Equals exceptions equals, some implementations do not use the above code point assignments for some characters. Precision ID. The Precision ID implementation of OCR-A has the following non-standard code points: OCR hook at U plus 007E, OCR chair at U plus 00C1, OCR fork at U plus 00C2, euro sign at U plus 0080. Barcode soft. The barcode soft implementation of OCR-A has the following non-standard code points: OCR hook at U plus 0060, OCR chair at U plus 007 east, OCR fork at U plus 005F, long vertical mark at U plus 007C, character arrays at U plus 0008. Moravia. The Moravia implementation of OCR-A has the following non-standard code points: OCR hook at U plus 007E, OCR chair at U plus 00FO, OCR fork at U plus 005F, long vertical mark at U plus 007C. ID automation. The ID automation implementation of OCR-A has the following non-standard code points: OCR hook at U plus 007E, OCR chair at U plus 00C1, OCR fork at U plus 00C2, OCR belt buckle at U plus 00C3. Sellers of font standards. Hard copy of ISO 1073-1 1976, distributed through ANSI, from Amazon.com. ISO 1073-1 is also available from TechStreet, who distributes standards for ANSI and ISO. See also, magnetic ink character recognition, optical character recognition, Westminster, a typeface designed to resemble the visual appearance of MICR, OCR-B. Notes. External links, introductory article about OCR fonts, links standard ANSI and SIDS 17 to 1981, background on ISO work involving OCR-A, Unicode code charts, IBM GC GID mapping.